This video is going to be part 2 of lesson 6, and in this video I'm going to be solving 2 of the homework questions, question number 5 and question number 7. So if you look at question number 5, it says prove that the exact value of the cosecant of 105 degrees is this answer here. So first of all, for sum and difference identities, we never talked about any reciprocal identities, and I don't want to deal with any reciprocal identities. So what I'm going to do is, instead of evaluating what the cosecant of 105 degrees is, I'm going to evaluate what the sine, what is the exact value of the sine of 105 degrees. Once I get that answer, in order to get the cosecant then of 105 degrees, I just have to take the reciprocal of whatever the ratio is. So the sine of 105 degrees, whenever they say that word exact value, that means we can't punch it into our calculator. It's got to do with the special angles. And remember that the 3 special angles were 30, 45, and 60. How could you use those numbers, 2 of those numbers, to get 105 degrees? And for example, you could take 60 plus 45, and that would give you the 105 degrees. So sine of 105 degrees, I could change that argument into a sum identity to be the sine of 60 degrees plus 45 degrees. Once I do that, I'm going to identify alpha, and I'm going to identify what angle is beta. From there, I'm going to take my formula sheet and find the identity, the sum identity for the sine, which would be this identity here. So now, using the right-hand side of this identity, I'm going to evaluate what the sine of alpha is and the sine of beta, cos of alpha, sine of beta. And from there, I'm going to see, does that equal root 6 minus root 2? So sine of alpha is the sine of 60 degrees. Cos of beta is the cos of 45 degrees. Plus cos of alpha is the cos of 60 degrees. Sine of beta is the sine of 45 degrees. Let's evaluate the sine of 60 degrees. So on my unit circle, at 60 degrees, the y value is root 3 over 2. Cos of 45 degrees would be my x value, which is root 2 over 2. Cos of 60 degrees, so now I'm looking at the x coordinate, which would be 1/2. And sine of 45 degrees would be the y coordinate, root 2 over 2. From here, let's evaluate each term here. So root 3 times root 2 would give you root 6. And 2 times 2 is 4. Plus 1 times root 2 is just root 2. All over 2 times 2 is 4. Okay, from here, what I could do is I could say that is equivalent to root 6 plus root 2 all over 4. From here, that is the answer for the sine of 105 degrees. But they don't want the sine of 105 degrees. They want the cosecant of 105 degrees. So the cosecant of 105 degrees, it's going to be the reciprocal of the ratio for the sine. So that would be equal to 4 over root 6 plus root 2. So you look at this and you say to yourself, okay, that's not what the answer was, right? They got, for their answer, root 6 minus root 2. So how would I change this in order to get that? What you need to realize is this is going to be something from Math 20-1. We cannot have radicals in the denominator, so we need to rationalize it. But because this is 2 terms, it's going to be rationalized by multiplying by the conjugate. So the conjugate of root 6 plus root 2 is root 6 minus root 2. What you do to the bottom, we're going to do to the top. Okay, what I will have is I will have 4 times that binomial all over root 6 times root 6 is going to give me 36. Sorry, it's going to give me 6. It's going to give me the square root of 36, which is 6. And then root 6 times negative root 2, that is negative root 12. Root 2 times root 6 is positive root 12. Root 2 times negative root 2 is going to be negative 2. So how it rationalizes is these two middle terms will always cancel. Negative root 12 plus root 12, that cancels. And what I get then is the cosecant of 105 degrees is 4 root 6 minus root 2 all over 4. 4 over 4 cancels or becomes 1. And then I have the cosecant of 105 degrees is equal to root 6 minus root 2. Let's look at the last question that I wanted to solve for you or with you, which is homework question number 7. So if we look at homework question number 7, this is going to be quite involved in order to solve this. But what we have is it says determine the exact values for. So they give me the cos and the argument is going to be a sum. And then the exact value of the sine of the argument is going to be a sum. So we're going to have two different identities here, two sum identities. What they tell us is they say to us the tan of theta is 4 over 3. And where this angle could be found is it's going to be less than 3 pi over 2. But greater than pi, which means that this angle is going to terminate in quadrant 3. So this is what theta would be. But what we need is we need to create our acute triangle. Tan, remember, is y over x. So y is 4 and x is 3. What you have to realize, though, is because we were in quadrant 3, in quadrant 3, x is negative, as is y. We need to figure out what r is using Pythagorean's theorem. So r squared is equal to x squared plus y squared. R squared is equal to negative 3 squared plus negative 4 squared. Remember to always put this in a bracket because negative 3 squared is 9 and negative 4 squared is 16. So that's going to give you 9 plus 16 would give you 25. Square root both sides, and you get plus or minus 5. However, a radius could never be negative. So r is going to be equal to 5. So the radius of this is 5. Why I need to know that is because now, remember that this was theta, right? That was theta. I know what the tan of theta is. And now I could write down, well, what is the sine of theta? So sine of theta is 7 yellow rabbits. So that would be negative 4 over 5. And I could evaluate what the cos of theta is, because I'm going to need sine of theta and cos of theta for when I do these identities. So the cos of theta, the ratio for cos is x over r, which would be negative 3 over 5. Okay, now that I have that, I'm going to determine the exact value for this and the exact value for this. So I've got actually two different identities happening. This identity here is a sum identity for cos, which would be this one. Okay, so that identity, cos of, let's actually write that down. The cos of theta plus pi over 6 is equal to, so let's identify alpha and let's identify beta. According to the identity, it's the cos of alpha, which would be the cos of theta, times the cos of beta, which is cos of pi over 6. And then it's going to be minus the sine of theta, times the sine of beta, which is a sine of pi over 6. So the exact value for the cos of theta plus pi over 6 is going to be the cos of theta, that is -3/5. The cos of pi over 6 is going to be on your unit circle. I'm just going to see if I put the unit circle anywhere. I did not. But pi over 6 is 30 degrees. And remember, at 30 degrees, the x-coordinate is √3/2. The y-coordinate is 1/2. So the cos of pi over 6 is the x-coordinate, which is √3/2, minus the sine of theta is right here, -4/5. Times the sine of pi over 6. The y value at pi over 6 is 1/2. Okay, evaluating this, what I'm going to have, -3 times √3 is -3√3, all over 10, minus, this would be -4 over 10. I've got common denominators of 10. My numerator, I'm just going to evaluate that. 2 negatives is going to give me a positive, and that would be, I could write it in one of two ways. I could write it as -3 √3 plus 4. The book, how it has it though, is 4 minus 3√3. That's how the book has it written. But again, you could have said -3√3 plus 4 would give you the exact same answer. So there's two solutions for this because they want us to evaluate two different sum identities. So that was the first identity that we evaluated. The second identity, you're going to do the exact same thing that I did, except now you're going to use the sum identity for sine, which is this here. Alpha is going to be theta, and beta would be pi over 6. So you're just going to simply, you're going to write this identity down, and then you would have theta here, and you would have pi over 6. You would have theta here, and pi over 6. So again, you're going to have the sine of theta. So the sine of theta is -4 over 5 times the cos of pi over 6. The x-coordinate at pi over 6 is √3/2, plus the cos of theta, which is here. The cos of theta is -3/5, times the sine of pi over 6. The y-coordinate is 1/2. This would evaluate to be -4√3 over 10, plus a negative, I'm just going to write minus. My denominator is 10, and that would be 3. Or you could have just had plus your -3 to see that. This answer, denominator is 10, -4√3. A positive and negative is going to give you -3. And that would be your answer for the second sum identity for sine.